that. Did I upload your last video? I think I did. I'm not. It's all right. So let's look at this. X-intercept, you want to set y as 0, okay?
Okay.
And then conversely, for y-intercept, you set x as 0. So that's the bottom line here. Let's do A. So this is f of x. Let's first find the y-intercept. It's a little bit easier. So the y-intercept is simply f of 0. We're just setting x as 0, okay? 0 minus 1, 0 minus 3, 0 plus 1, 0 plus 4. These will make it a positive 3 times 4, it's 12. So the y-intercept is 12. Now for the x-intercept, we want to set y as 0. So y is f of x. So this is 0 equals x minus 1, x minus 3, x plus 1, and x plus 4. All right, look at this equation. How do we solve for x?
Oh, well, you'd have to expand it, I guess.
No, you don't. Do not expand it.
Oh, you don't?
What if it was a quadratic? Let's forget about these two. What if it was just this? How would you find the zeros? Quadratic in a factored form. No, don't FOIL it.
Oh.
You want to set them, each individual brackets equals to 0. Okay, one by one. So here, you want to set x minus 1 equals 0, x minus 3 equals 0 in a quadratic, right? And then x, or you can just flip the signs. This is what you're doing technically, but if you just want the zeros, you just flip all the signs. So you get 1 from this, you get 3 from this, right? And you'll get x as negative 1 from this one, and then x as negative 4 from that one.
Oh, yeah.
Is that good?
Yeah.
All right, that's step 1 done, x and y-intercept. Step 2, identify the degree of this function.
Is it 4?
Yes, it is 4. Oh, is the leading coefficient positive or negative?
Positive.
Positive. So 4 degree, it's called a quartic. Starts there and ends here, okay? Starts here and ends here. Okay, and looks something like this. Looks like a W. A positive quartic polynomial, 4 degree. So now we're just gonna make a sketch and join the dots. So from here, it's very easy. So our y-intercept is 12. Again, I'm just gonna make this as 12. And our x-intercepts are 1, 3, negative 1, and negative 4, right?
Yeah.
And now it's just a matter of connecting all the dots. So we know we start here, and we know we end there because a positive 4 degree polynomial. And then we just connect all that. So it's gonna come through the first x-intercept, it's gonna go through here, it's gonna go through the y-intercept, gonna come down here, and boom, there we go. That's the answer.
Okay.
By the way, see, there's a reason why it says a possible graph of this function, because in this course, for this exact question, there's an infinite number of graphs. I could have drawn it this way. So it's going to come down here, but instead of it just going back there, it's going to go back all the way here. And then instead of it going back at the y-intercept, it's going to go back somewhere else. Although all the intercepts are the same, but it does not necessarily have to go back where it did. Okay, so there's an infinite number of them. So key point here being for you, for this course, it doesn't matter where this is, as long as you have your intercepts right.
Oh, okay.
You don't have to worry about these turning points.
Oh, okay. And
now,
also, just like about the turning points, I'm actually not sure how to phrase the question, but for like your degree that you have,
yeah,
like how do you know how many turning points there should be, or like what possible turning points there could be for each degree?
Okay, so for an odd degree polynomial, so what I mean by odd degree, y equals x, like odd degree, right? For example, x, x3, x5, yeah?
Yeah.
Turning points. So it's either 0, okay? 2, 4, but in this form, it's gonna be an even number up to a maximum of the degree n, let's say the degree is n minus 1. So what does this mean? This means for a cubic function, right? We know it starts here and ends there, positive cubic. It can have either no turning points, look something like this, or it could have 2 turning points because the maximum is 2, n minus 1. So it's going to look something like this. 1 turning point, 2 turning points.
Okay, so it's 0 and 2, it can't be 1?
No, it cannot be 1.
No.
For an odd degree polynomial, it can't be 1. For an even degree, so for example, x squared, x4, so turning points, there has to be at least 1 up to a maximum of n minus 1. So let's say x4, like here, see it has 3 turning points, but it could have just had 1.
So is it like possible from like 1 to 4, or are there some that are just impossible?
So it's either gonna have 1, okay, 3, 5, and such. So a gap of 2 each time, actually. Just like here, a gap of 2. Same thing here. So it can only have like an odd
from
number.
1.
Yeah,
Okay.
odd number of turning points. So an even degree function has like an odd number of turning points. Can it have 2 turning points? No, it cannot.
Okay, so odd degree, even number turning points, even degree, odd number turning points. Oh, okay. Okay, that makes sense.
All right, let's do part B. You want to do this?
Yeah, sure.
Again, so to graph it, we need to find the x and the y-intercepts. To find the y-intercepts, it's easy. It's right here, it's going to be 0. How do I know that so quickly? Because f of 0, just plug these as 0, it's going to be 0. So that's our y-intercept. To find the x-intercepts, you have to factor it, okay? So let's see if we can factor it. What can we pull out here?
Negative x.
Yeah, we can pull out a negative x. What am I left with in the bracket?
A 2x minus 3 bracket.
So 2x squared plus 3x minus 9.
Oh, okay. Can you keep it as like 2 brackets? Like if you were to do 2x minus 3 and then x plus 3? Or is it better to have it?
No. If you can factor this further, yeah, you need to factor it further as well. So what did you say it was? How did you do that so quickly? You already had it done.
It's B, right? That's like I started B.
Okay.
So like I got to that point.
All right, so this is how I do it. I don't know if I did it with you like this. So I'm looking for 2 numbers that multiplies to a times c, so that's negative 18, and they're going to add up to the middle value 3, right? So it's going to be a positive 6 and negative 3.
Yeah.
So I'm going to rewrite this as 2x squared plus 6x minus 3x minus 9, and then I can pull out a 2x from the first 2. So you have 2x x plus 3. I'm just factoring it, and then I can pull out a 3, x plus 3. And so this thing in the factored form is minus x, 2x minus 3, and x plus 3. Okay?
Yeah.
And now to find the y-intercept, you simply plug x as 0. We could have done that here, which I did. If you plug x as 0, the y-intercept, f of 0 is 0. To find the x-intercept, you want to set the factored form, okay? The factored form equal to 0. The y value in the factored form equal to 0. So what are my x-intercepts here?
0.
Yeah.
Is one of them.
Mm-hmm.
A negative 3.
Yeah.
And 3 over 2.
Yes. So that's 1.5, right?
Yeah.
Okay, there we go. Now it's easy. So we have all the x-intercepts and the y-intercept. Now we're just going to make a rough sketch. We know the y-intercept is 0. And we know the zeros are 0. Well, that's in the so passes through the origin, minus 3 and positive 1.5. And this is a negative cubic polynomial, yeah?
Yeah.
The leading coefficient of this degree term is negative. So negative cubic starts there and it ends there. Yeah?
I thought it was I thought it was
you're right.
2 to 4.
You're right, actually, yeah, it's a negative. So it's gonna start here and it's gonna end here. Yeah, that's right. It's a reflection on the x-axis.
Okay. And sorry, like I just had another question
Yeah.
for end behaviors. Do you like our teacher didn't really explain it, but do we write like the quadrants or is it
No, you
like
don't. You write infinity. So let me just make a sketch of this,
infinity
and
notation?
we'll write the end behaviors for this. Now just connect the dots. Notice this one has 2 turning points. That's one possible. Like I said before, there's an infinity. You can pull it all the way down, and then maybe the turning point is there. Okay. This is one possible sketch of this function. So in terms of the end behaviors, so this is an odd degree function. So that means the end behaviors will flip-flop. That means as x goes to negative infinity, where's y going?
It's going infinity.
Yeah, y is going to infinity. And what about on the other side? As x goes to positive infinity, where's y going?
Negative infinity.
Yeah, exactly. You see, if it's an odd degree polynomial, then the end behaviors are different for the y. Whereas if it's an even degree polynomial, like a was a quartic, right? It was like a w. For this, the end behaviors will be same. As x goes to negative infinity, y is going to positive infinity. And as x is going to positive infinity, y is still going to positive infinity.
Okay, so like just to like clarify, when it's going like up
Hmm.
and to the left, it's positive. I mean
Yes.
positive infinity, then down and to the right, it's negative infinity.
Yeah.
Okay.
It could be negative infinity like this as well. Over here, it's negative. So as x goes to negative infinity, y is going to negative infinity.
Okay.
Here, where's y going here?
Infinity.
Yeah.
Okay. Okay, that makes sense.
Alrighty. Let's do the next one. What are the next questions?
The last question is 8.
All right, this one's interesting. So what's going on here? They've given us a cubic polynomial and they've asked us to sketch the absolute value of this, yeah?
Yeah.
So now the question for you is, what does the absolute value do?
Well, it goes like a V.
Yeah, it's
sort
always
of.
gonna be positive, yeah? Yeah, the parent
Yeah.
function goes like a V, but here this is the absolute value of this, right? So what does that mean? That means the y values will always be positive. Okay? This
Okay.
means
Oh,
the y value will always be positive. X values stay as they are. The y values are positive. Cool?
oh, wait, what do you mean by that? Like for like the y-intercept or?
No, all the y values.
Oh, you mean for like the end behavior sort of? Is it all going
All the
towards
individual
infinity?
y values,
Yeah.
x values stay the same. X, whatever it is right now, like -4, -4.1, x value is the same, but the y value, they're all gonna be positive. Here, let me show you. We're gonna divide this graph just to make it a little bit clear. We're not interested here. Here, nothing's gonna change because the y values are already positive, and even like here, y values are already positive, yeah? Nothing's gonna change. So the only thing that's gonna change is where y values are negative. So here, to the left of this, and between this and this, okay?
Okay.
The x values are gonna stay the same, but the y values, they are gonna become positive. That means it's a reflection on the x-axis for the y values. So it's gonna go there. This guy here is gonna go up there. Same thing with this. All the y values down here are gonna become positive. So it's gonna look something like this. So your final
Okay.
graph there looks like this, like this, like this, and then like that.
And is that still an odd degree?
Yeah. Although no, the degrees are explicitly only for polynomial functions. Like when we say degree, we mean like we're talking about polynomials. Now this is no longer a polynomial function.
Oh, okay.
So the degree nomenclature doesn't really apply to this.
Oh, okay. Okay. That makes sense.
Let's look at B. B is very similar, but now what's happening there? All the y values are going to stay the same, okay? But the x values are all going to be positive.
Okay.
So where are the x values negative? X values are negative to the left of this, right?
Yeah.
So it's going to look something like this. All the y values. So it's a reflection on the y-axis. So I'm just reflecting this bit, okay? Because that's where the x values are negative. And we can't have negative. All the x values need to be the positive. So y values are going to stay the same, but x values are going to flip. So this will actually not be a function. So it's going to look something like this.
Okay. I'm like a little confused about this question because like in the answer key, I think it looks a lot different.
It
It's like
does.
a W. Yeah, I think.
All right, let's check that out. Maybe we did something wrong. This was question 8, right?
Yeah.
Well, we got this right. We messed this one up. Absolute value of x. I mean, when in doubt, you can always plug in some values. So they reflected, I think they did this, right? Yeah, they did that. So what did we do wrong? We said it was like that. So I made all the x values positive, but that didn't work out. So let me just plug some points into this. So let's say that is -1, and let's say that's +5. So on the main function, you have -1 and +5, right?
Yeah.
And in the transform function, what are they doing? They're just taking the absolute value of the x. How did that point go down there? So this point became negative for them. Yeah, that's what it looks like. So the y values stayed the same. Yeah, that's what I did. But the x values, they became positive. I'm not sure about this because here the x value is going to be negative, right? To the
Yeah,
left of
but
this, all the x values are negative.
okay. Yeah, I didn't know for if it's the absolute value had to the x's like had to be positive if it was for the y or x's.
Yeah, I'm not sure how they got this point. So how does that work? So that point is like -1, -5, yeah? So
Mhm.
if you do f of -1, let's try that, f of -1. So you will get, maybe you have to do all the points individually by hand. So that'll be just +1 cubed plus 1 squared minus 6. So that's -4. Okay, I think that's what they did. They just did all the points, like a couple of points. You don't have to do all of them, like by hand. Look at this. F of -1 gives me -4. Okay. So before f of -1 was +4. Okay, so 1 was probably somewhere here. Before it would have given me a +4. Okay. But now, if I were to plug f of -1, it's going to give me a -4. Here, let's look at it for this point. I'm going to say that's f of 3. So before, looks like it's a 5, yeah? F of 3 is a 5, or -3 is a 5. But now in this function, what do I do? F of the absolute value of -3 is equals to, you see this x? I'm going to replace that with a 3. 3 cubed plus, you see this? I'm going to replace that with a 3 squared. Because the absolute value of this will always be a positive number, right? -6 times, what, 3? What does that give me? 3 cubed is 27 plus, right? 3 cubed is 27 plus this is a 9. 36 minus this would be an 18. Is that what they have? Yeah, -3, it's right there. So I think what they did for part B here is they just plugged out a couple of points to see where they land.
Oh, okay.
I thought it was a reflection on the y-axis, but it's actually a reflection on the x-axis. Once
So
you
would
pick
you
a,
just
yeah,
would
once
you
you do a
guess
couple
the
of
point?
points, no, yeah, once you do a couple of points, you'll see the pattern. Just pick like 3 points. Pick one like here and here.
Okay.
This one ends up
And
being where it is, but this one comes down there. And 0, 0 is gonna stay at 0, 0, and then you can just connect the dots.
oh, okay. And for like f of -3, why did you remove the negative when you're
Well,
putting it
because
in?
the absolute value of -3 is +3.
Oh, okay.
Because the absolute value function.
Okay.
Yeah,
Okay, yeah, I got it.
yeah, it was a little bit easier because you were just looking at the y values. B was a little bit tricky because this graph represents the y values, right? So for that one, you might want to pick a couple of points to see where
So
it's going.
would it be better to do it for the y value too, just in
Yeah,
case?
yeah.
Oh,
But y
okay.
value is a pretty safe bet though, because what this means is that y will never be negative. So you can just remember that y will never be negative. So it's gonna look like this. But this one, I thought x could never be negative, but that's not the case. X can be negative. So this one, you're gonna have to do it by hand.
Okay. Does it apply to everything, like the
Yeah,
absolute for y?
yeah, yeah. So any
Okay.
function they give you, like let's say they give you 1 over x. Okay, let's say this is f of x. And then we want to plot the absolute value of f of x, right? The y values. Our graph initially looks like this. Yeah?
Yeah.
But notice all these y values are what? Negative, right?
Yeah.
So they will all become positive. So the x values are going to stay as it is, but the y values will be positive. And there you go. That's going to be the final graph.
Okay. Okay, yeah, I see. Okay. I wanted to go to equations, no, graphs of polynomial functions in factor form. That section. And like just do random questions like 1 to 5 first.
Cool. There's a lot of them.
Yeah.
Let's do one by one. Because I don't have enough space on my page for all of this. So
Oh,
let's look at the first one. So that's this one. What's the degree of this polynomial?
the degree of 3.
The degree is 3, right? But what are the zeros?
It's 0 and 1.
It's 0 and 1. So it's a positive cubic, right? It's going to start here. It's going to end up here. Yeah.
Yeah.
The y-intercept is 0 because if you plug x as 0, the y-intercept is going to be 0. And at 1, there's a turning point. You see the order of this factor? Whenever something is squared, it means there's a turning point at that 0. So at 1,
Oh,
there's going to be
really?
a turning point, yes. So it's going to go through the first 0 at 0, and then it's going to go through this 1, but there's a turning point there. It's not going to cross that. So that's what the graph of A looks like.
Okay, and like again, because it's degree of 3, there can only be like, would it only be 0?
Degree of 3 means maximum of 2 turning points, either 0 or 2.
Oh, okay, 0 or 2.
Yes,
Okay.
so which one does that resemble? That resembles a turning point at 1, so it's going to be this one, V, yeah.
Okay.
So 5 is out of the question, right? Let's do it for the next one. You got that?
Yeah.
The first one is 5. B. So this is a quartic polynomial. That means it's a degree 4, yeah?
Yeah.
And we know it's negative, so that means it's a reflection on the x-axis. It's gonna look like an M. So it's gonna start here and it's gonna end here. Good?
Oh, okay. So quadrant 3 to 4.
Yeah, because it's a
Okay.
negative degree 4 polynomial. And we know the zeros are where? For B.
1 and negative 2.
Yeah, that's good. So at 1 and negative 2, there's zeros. And if you want to be a little bit more precise, you can just plug x as 0 to find what the y-intercept is. It's going to be negative 4. Okay?
Okay.
And then now it's just a matter of you, oh, by the way, again, you see what's the order of the factors? You see this one's an order 2 factor, right? If it's
Yeah.
an order 1 factor, it's normal. There's nothing fancy going on. Both of these are order 2 factors. That means there's turning points at both of those zeros.
Okay.
So we're looking for an M-shaped graph that has a turning point at positive 1 and negative 2. So it's going to be VI is the sixth one.
Okay. And for the turning points,
Mhm.
would it be like 1, 1, 3?
So there's 3 turning points here. Yeah, at least 1 up to a maximum of 3 for a degree 4 polynomial.
Okay. So is it like 1, 2, 3?
No, no, no
Or is
2,
it
no 2.
no 2? Yeah. Okay. So is it
Either 1 or
is it
3.
just 1 or 3? Okay.
Yeah.
Would you go about C the same way?
Same way. We know it's a negative quartic, right? Or degree 4,
Yeah.
x3 and x. And we know the first 0 is at 0 and the next 0 is at negative 1, right?
Yeah.
But there's another trick you need to kind of, I'll let you in on. And again, it's all quadrant 3 to quadrant 4, negative quartic. Yeah?
Yeah.
So notice when x is 0, that's an order 3 factor. When it's an order 2 factor, it's a turning point. When it's an order 1 factor, it's just a normal, it just crosses that 0. But when it's an order 3 factor, that means there's a point of inflection, or there's like a mini cubic polynomial there. So how could that possibly look like? Here, let's look at this. It's going to go through negative 1 as it is, okay, like that. But at 0, right, this is an order 3 factor, there is going to be a point of inflection, it's called, or like a mini cubic function. If you zoom in here, it's going to look like this. A mini cubic function there.
At 0?
Yeah.
Is that only for cubic?
Yes, that's only for cubic. So which one of them fits the bill? This one. It's the third one, I. So at 0,
Okay.
there's like a cubic function there.
And is like cubic only what paired with like an x by itself, or can it be in with the bracket? Like if it was x plus 1 cube.
Yeah, it could be anything. Like if it was x minus x plus 1, 3. So that means at negative 1, there's also a cubic function. So this is a negative degree 6 polynomial. It's going to start here. It's going to end here. Yeah.
Yeah.
So this means it's going to look something like this. So there's going to be, again, let me draw this more precisely. It's going to just come up normal like this, but at negative 1, there's like a cubic function. Yeah. Like a mini cubic function. And again, at 0, there's a mini cubic function, but it's a negative cubic at 0. And there we go.
Wait, so is like kind of going in like a line
Yeah.
at negative 1, like on the x?
At negative 1 on the x, it looks like, yeah, it's like a line. It's like a cubic function, the parent function. Like this, like this.
Okay.
So that's when it's an order 3 factor.
Factor?
Yeah, like an order 3 factor. What do I mean by
Okay.
that? You see, these are both order 2 factors. The polynomial is degree 4, right? Degree 4. But the factors individually, they're order 2. That means there's a double turning point there.
Okay. Okay. And like for the turning points again, it would be like 1, 3.
Yes.
Okay. Oh yeah, I understand.
It's the same idea for D and E. We can just make a quick sketch of this. So D is a degree 4 polynomial, yeah? Positive. It's going to start here, it's going to end here. The zeros are at negative 2. And at positive 1, there's like a cubic polynomial there, hidden, okay? The y-intercept is -2. I just plugged 0 in there. So what does that look like? It's going to look like this. So here, there's a cubic function. So this one, even though it's a degree 4 polynomial, it only has one turning point. So D is I. And notice at +1, there's like a cubic function there.
Oh, okay. Yeah, okay, I see it now. Clear.
And this only has one turning point. Only here, down here. That's not a turning point. Turning point
Turning
means
point, yeah, okay.
it flips, right? It's going up and then comes completely down. This is not a turning point. This is what's happening here at 1. That's not a turning point. If you want to be technical, that's called a point of inflection.
So is the point of inflection, like, would you say it's 1?
There's a point of inflection at x equals 1.
X equals, oh, okay. And it always like goes like in a line.
Yeah.
Sort of like it curves. Oh, okay. Okay, I see.
And then the final one, what's the degree of E?
It's 5.
Yeah, exactly. So it's a quintic polynomial, but it's reflected, right? So instead of starting from 3 to 1, it's going to start from 2 to 4. Yeah?
Yeah.
And the zeros are at -1. There's a square, so that means there's a turning point there. And at +2, there's a cubic polynomial there. And just for simplicity, I'm just going to plug 0 in here. -2 times 2 is +4. So the y-intercept is at +4. So our function is going to look like this. At -1, there's a turning point given by this degree 2 factor. It's going to come to the y-intercept, and then it's going to do like a cubic function at +2. So for E,
Okay.
which one is that? That one is this one, 7. VII.
Oh, okay.
That makes sense?
Yeah. So if it's cube, there's always a point of inflection, was it?
Correct. If the factor is cube, that's a point of
Cube.
inflection.
Oh, okay. Is it so it's only for cube, not for
Yes.
anything else? Okay.
Nothing else.
Okay.
Oh, and what I call degree, your book is calling it multiplicity. That's what I meant by degree. So here, -2, oh, sorry, that doesn't apply here. +1, the x-intercept of 1 has a multiplicity of 3.
Oh, okay. I was confused about that because we like in class we also call it degree. So I
No,
didn't
I was
know
calling it
what
order though. No, degree is something else.
so
Multiplicity.
okay, that means order.
Yes, it's a little bit hard to pronounce. Multiplicity.
Okay. Yeah. Okay.
So this a quadratic function with a negative leading coefficient. So we know it's going to open upside down, and it has a 0 at -5, and multiplicity of 2. That means there's a turning point. That's an order 2 factor, like that. X plus 5 whole squared could be a potential equation.
Okay. So that's it.
That's it. Yeah. Once you know how to do like a couple of them, like the whole thing becomes very clear. The next one is a 5th degree function with a positive leading coefficient. Well, now they're calling it order though. So I guess they mean the same thing. Multiplicity and this means the same thing.
Okay, I thought it meant different things. That's why I
No,
was-
it means the exact same thing.
Okay.
So a 5th degree function with a positive leading coefficient. So it's going to start here and it's going to end here. A 0 at the origin, all right, of order 2. So that's a turning point there. And a 0 at x equals 3 of order 3. So that means there's a point of inflection at x equals 3.
Oh, okay. Okay.
What
Yeah.
could be a potential equation for this here? Let me ask you that.
Well, it would be y equals x to the power of 5 and negative. No, it's positive. And then
No, x to the power 5
oh.
is wrong. You're already wrong. Try
Oh,
again.
really?
It's in the, you have to look at it from a factored forms perspective, right? You see this one at 0, there is a turning
Oh.
point. So what does that mean? What's the
Oh, is
power
it
of
negative?
x?
Oh, never mind. Why
So
code?
what's the power of x? We know x, yeah, it's gonna look something like this. X squared, okay? That means a 0 at the origin, right?
Oh, okay.
What about this one?
For 3,
Mhm.
well, there'd be a 3 on the outside as an exponent, like
Yeah,
as a
good.
power,
Yeah, and then
and
what's in the
then
bracket?
x minus 3.
There we go. That's the
Okay,
potential
yeah.
equation for this graph.
Okay. Oh, yeah, that makes sense because 2 plus 3, 5. Yeah. Okay.
Okay, do you know the difference between multiplicity, order, and degree?
Yeah. So order is just like the exponent, like not like the power outside the
Yes.
bracket, and then degree is like adding those up.
Yeah.
Okay.
So it says a quartic function with a positive leading coefficient. So we start here, we end there. Quartic means degree 4. With 2 real zeros at x equals 0 and x equals 3 of order 2. Do you do like complex numbers?
No, not really, not now. At least because this is like a completely new concept.
Yeah.
Yeah.
Interesting here. This is 2 real zeros. Anyways, this one's very simple. You just, there's a turning point at 0, and then boom, boom, the turning point at 3, and you're done.
What
Potentially,
is it like?
yeah,
Oh, sorry. I was just gonna ask, like, does what's the point of saying 2 real zeros? It's just 2 zeros.
yeah.
Okay. Well, like, would it be the same thing if it was just 2 zeros?
Like sometimes, right? You have something like this. I mean, we did complex numbers, right? I think it was you, your grade 11 teacher who introduced you to complex numbers, if I remember correctly. So you have something like this. Yeah. So let's say you have x squared equals -4. What is x?
It would be 2.
Nope.
What?
Did we do complex
Yeah.
numbers in grade 11? It was you, I think. Maybe not. Maybe I'm
Mm,
misremembering. It's not gonna be
I'm
2.
not sure. No, I don't think so.
All right, then don't worry about it. It's gonna be plus minus 2i.
I?
Yeah.
Okay, no,
Okay, then let's
I
forget
don't.
about it. Actually, no, don't forget about it because it's something
Okay.
you're gonna be using in the university a lot. Even in the calc and vectors course, this is gonna pop up. So you know how you say you can't take a square root, right? How do you solve for x here? You take the square root of -4, yeah? And at this
Yeah.
level, whenever you're taking a square root, it's a good practice to put a plus minus.
Yeah.
This one, you can't do it in the real number system, okay? But you can do this if you jump the system into something called complex numbers. And what's the idea there? The idea there is this. The square root of -1 is like pi. It's a constant. It's called I. What I'm going to do here is I'm going to rewrite this as plus minus square root of 4 as it is times the square root of -1. Because square root of 4 times square root of -1 is square root of -4. Yeah?
Yeah.
So plus minus square root of 4, that's plus minus 2. And square root of -1 is I. There we go. This equation has 2 zeros, has 2 complex zeros.
Oh, okay.
Okay, it has no real zeros, but it has complex zeros. And eventually in university, what are you planning to take if you know?
Well, I was leaning towards the health sciences.
All right, maybe you'll see this if you take, you have to take at least one math course. So you will definitely see this
Mm.
I thingy. And the question will be very similar to this. It'll be this, and then it'll be with 2 real zeros, and it's gonna be with 2 complex zeros. Because a
Oh, okay.
quartic function can have 4 zeros, right? So 2 from the real system, 2 from the complex system.
Okay.
Yeah, that's a little bit advanced, but there you go.
I maybe last year you might have mentioned it,
Mhm.
but like, yeah, no, I don't think in class we did anything like this.
So there do exist other zeros apart from real zeros, but
Okay.
if you're not, if your teacher hasn't covered this, then don't worry about it.
Okay.
So that was that question. I think you can do the rest, right?
Yeah.
It's very similar. Let's move on to the next one. Question 3. Even this one is very simple. State the degree. What's the degree of the first one? F of x.
3.
That's good. What about the g of x?
5.
Yeah, super simple, right? Nothing fancy going on here. State the x-intercepts and the y-intercepts of each function. So again, here, let's do the y-intercept first, because here I can already tell both of them are going to be 0, because if you put a 0 here, 0 times anything is a 0. Same thing here. Y-intercept is when x is 0, right?
Yeah.
So if you put a 0 here, if you put a 0 here, the entire thing is going to be 0. So the y-intercept for both of them are 0. That means it goes through the origin. Now for the x-intercepts, we have to think about it a little bit. What are the x-intercepts for f of x?
Well, 1 is 0.
Yeah.
1 is -5.
Yeah.
And then it would be 2/3.
Yes. What about the other one?
It would also 1 would be 0.
Yeah.
I think, yeah. And then 2.
Here's a quick tip. If the y-intercept is 0, x-intercept has to be 0.
There has to be 1.
Oh, no,
that's
the 0, 0, yes. It means if the y-intercept is 0, that means it's going through the origin. So the x-intercept must be 0 as well.
Okay.
Describe the end behaviors of each function. Again, kind of simple. We know this is a degree 3 polynomial, but it's negative, right? So it's going to start from quadrant 2 and end up in quadrant 4.
Okay.
So as x goes to -infinity, y is going to +infinity, and x goes to +infinity, y is going to -infinity.
Okay. Is there like how do you know what end behaviors like for what? Like is it just like the same for odd degrees and same for even degrees, like
Yeah,
depending on the coefficients?
Yeah, but it might be negative, so you need to flip it around. Just make a quick sketch right here. What I noticed was this is a negative cubic polynomial, so it's gonna start there and end there. Yeah.
Yeah.
So that means this represents x is -infinity. When x is -infinity, y is +infinity. Same thing here. This represents x +infinity. As x is going towards +infinity, what's the y value here? The y value there is -infinity. So I just like to make a quick sketch to see where it's headed. And this is an odd degree polynomial. That means the end behaviors will flip-flop. So it'll be +infinity and -infinity on the y. For the x's, this is the rubric for any, whenever you're writing end behaviors, you will always write as x goes to -infinity and as x goes to +infinity.
Oh, so okay, so the x's are always negative to
And
positive.
Yes. This is always the
Okay.
case for anything. And then the y, it depends, right? Here, tell me for this one. Which quadrant does this start and where does it end?
So 5 odd positive. So would it be 1 to 2? Or
5,
no.
no.
Oh no, sorry. It it would be 3 to 1.
Yes, 3 to 1,
Yeah.
right? So as x goes to -infinity, where's y headed?
Negative.
Yeah, there we go. What about on the other side?
Positive.
Yeah. So an odd degree polynomial will always have the zigzagged end behaviors.
Okay, and also for like the x's,
Mm.
if it's just going to the left is a negative, or does it like even if it's going up or down?
Yeah,
Like,
x is always negative here. See, if for this one, as x is going to -infinity, y is going to +infinity.
oh, okay, so for x's, it just has to be like to the left.
Yeah.
Not like doesn't matter if it's up and down.
No.
And same for
On the
okay.
positive side, yes.
Positive.
So we're only
Oh,
concerned
okay.
with this. It's always gonna be this one, okay? Any end behaviors you write, you're gonna rewrite this every single time. The only difference will be where the y is headed.
Okay, that makes a lot more sense now. My teacher hasn't explained any of this to us.
Yeah, that's fine.
Yeah.
And graph
Okay.
the function is just a matter of joining the dots once you have the x-intercepts and stuff.
Okay.
So we're just gonna skip that. Let's look for something a little bit hard. And all these are pretty similar. Let's try working up from down to up. Actually, this one looks interesting. Alrighty, it says determine a actually, I'm gonna spice this a little bit. Actually, do we need to spice this up? I'm gonna spice it up because I'm gonna say that point is -3 and +3. I'm gonna give you a point as well. Okay, we're just making this question a little bit harder. What is a possible equation for this graph?
So like, would you first determine the zeros? Would that be the easiest way
Yeah,
to
sure.
go about it?
Yeah.
Okay. So one of the zeros would be -3, but like in the equation it would be +3.
So it'll be x plus 3 like that.
Yeah, and then bracket, I guess.
Yeah, f of x is x plus 3, and then
Um, and okay, would it be to the like power of 2 because it's kind of like turning? No, it's not. It's not turning, is it?
no, it's not turning there.
No,
It's
turn
passing
okay.
through. It's passing through normally. That's linear. If you just zoom in here, it's a straight line. That's linear.
Linear. Okay, but for like the zero, it would be to the power of 3.
Yes. So I'm just gonna write that in the front.
Yeah, here. And then for -4, like x minus 4, would the power be to the power of 2?
Yes, it would be.
Okay. Are those all the zeros? Yeah.
They are, yes. But this is not quite right. It's right, but it's
Okay.
you won't get an A plus with that. Why though? What are we missing? We're missing something here.
Does it have to do with the point?
No, ignore the point. The point we'll do after we're done with this. This is a positive degree 6 polynomial, right? This is a
Oh, it has to be
negative.
negative.
Yeah, so just put a negative sign there.
Negatives. Okay. Yeah, okay, I was about to say that.
Right, that is the answer to this question. But now we're going to find out exactly what the coefficient is, okay, using this point. So whenever you're doing a question like this, there is the leading coefficient is in the front. It's going to be A.
Yeah.
And now we're going to plug the y value here as f of x, that's 3. And then we're going to plug x as -3 to find exactly what A is, and it's going to end up becoming a negative number. Okay, like that. I'm just going to plug the x's as -3 and the y as the 3. So this is, actually it doesn't work, does it? -3 plus whatever, it does work. So -27 times +49. That's a big number, but doesn't really matter. -1323, and this is a 3, yeah?
Yeah.
Divide both sides by that, and -1323, and there we go, A is negative. That's another way of showing the A is negative. So if they give you a point, you have to find the A value as well.
Yeah. Okay, I think we've done a couple questions like that.
These don't count as points though, because if you plug 4 in there, you'll get the entire thing 0. That's why this kind of didn't work as well, because I just picked this up. If you notice, this is a 0 here because I made up the question. But just ignore this. This is still the main point here is that A's should be negative, and you'll see that if they give you a point apart from the x and the y-intercepts, because you can't plug them back into the equation. You'll get a 0.
Okay.
All right, we're moving upwards. So let's try number 10. Or is there anything else apart from whatever this is, 2 point?
We can go to module 5, I guess, like the equations of polynomial functions in factor form.
All right, let's do some hard ones from this one. Oh, you see I thing, it showed up here. Right there.
Oh. I mean, we haven't learned it, but I don't think it's one of my homework questions.
6C and D.
Oh no, it's
It's not?
But we can do them.
Well, yeah, let's do them. Why not? It says find the general equation of a quartic function which has these as the z. Actually, this is a little bit easier. Let's try this one. Yeah, this one looks more interesting. So they've given us the zeros, and we're supposed to come up with the equation.
Okay. So it's because it says it's going to be x to the power 4. Like,
Yeah.
oh no, like the degree is going to be 4.
Hmm.
Okay. And then for the zeros, can you put it in as 3 plus minus square root of 2?
No,
Or you can't do that?
no.
Oh,
1 0 at a time.
oh okay.
So it's gonna be this. I'll give you the answer. It's a little bit tricky, but it's not really though. So we always do x minus something, right? So the first 0 is
Oh, yeah.
x minus 3 plus square root of 2 times x minus 3 minus square root of 2. There we go. Those are the two real zeros.
Oh, okay.
And now I'm just gonna plug the other two complex zeros. Minus 4 plus I root 3. And then finally x minus, always x minus, yeah? Minus
Yeah.
4 minus I root 3. And there we go. That's the answer to this question.
Oh, what happened to the like x minus bracket 3? Or are we not done? Or is that
We're
it?
done. We're done. This is it.
Oh, what happened to the 3 plus minus square root of 2?
Yeah, so that's either 3 plus square root of 2, that's one of the zeros, and 3 minus square root of 2, that's the other zeros. I have them here.
Oh, are you just listing the zeros? But what
Yeah.
about the equation?
The equation is this. If you just multiply all of them together, right? Like if the zeros were 2 and 3,
okay.
you'd do x minus 2x times 3. That's what I did.
Oh, okay.
Do you get this? If the zeros are 2 and 3, for a quadratic, it's going to be x minus 2, x minus 3. Let's say it's a quartic function and this has a multiplicity of 3, then it'll be x minus 2, x minus 3 cubed.
Okay, so you just put it
Yeah.
beside each other. Okay.
And that's all
Yeah,
there
yeah.
is to this one. I'm surprised it popped up here because this is not part of the curriculum. Complex numbers for advanced functions, it's not. Maybe they want you to kind of go a little bit ahead of the curve.
Can we maybe do question 8? I haven't done it, but
Yeah, so let's first make a quick graph, yeah? I'm just gonna plug x as 0 so I get the y-intercept. So 4 times 416 divided by 4. The y-intercept is positive 4. I just plugged f of 0 to find the y-intercept to make the sketch.
okay.
So our two zeros are at -2 and +2, yeah?
Yeah.
So which quadrant does this start? Where does it end?
It's one or two, like quadrant 1 and 2.
Yeah. So notice both of these have multiplicities of 2s, yeah? So there's gonna be a turning point at both those locations. So we start there, we end there, positive quartic, gonna go there, turning point, and it says the y-intercept is a turning point as well. And then there's a turning point down there as well, like that. Okay?
Okay.
And that's the sketch. Part A, the intervals where f of x is positive and f of x is negative. Well, it's positive everywhere. So it's positive from -infinity to positive infinity. Right? It never goes below the x-axis. Yeah?
Oh, okay. So would that be the okay, yeah.
But I'm not sure if you need to divide this. We could say it's like this. I'm not sure which one they want. Actually, we're gonna have to double check this because at this point, the y value is exactly 0. 0 is neither positive nor negative. So I'm curious to see whether they did this. We'll check this in a little bit. So what I did here was it's positive everywhere apart from -2 and +2. At exactly those points, the y value is 0. So 0 positive number, well, it's neither. So we're gonna have to double check which notation they used.
Wait, what do you okay.
Because positive means like 1, 2, 3, 4, 5, right? But
Yeah.
at this point, precisely the y value is 0. So does that point count as a positive number? I would assume not, but let's see. If it does, then this is the answer. Not a whole lot, not hard, everything on the x. If not, it's gonna be this answer.
What does two, like, is it 2 to infinity or 2 to 2?
Yeah, 2 to 2 means from here to
Yeah.
here. It's positive, apart from 2 itself, because at exactly 2 and -2, the y value is 0. That's what that
Okay,
means.
so would it be -2 and 2? What?
Yeah,
Or
exactly.
is
My
it?
bad. Yeah. This should have been a
Oh,
negative. Yeah.
oh, okay. And
Now
then what about, yeah,
this one for a fact, I know you don't include those points.
okay, because it's
Yeah, because
only increasing, so
yeah,
it's increasing,
yeah. At this point, it's neither increasing nor decreasing. So increasing is gonna be from -2, yeah, to 0, exclusive, right? It's increasing there, and it's also including, I'm right, a union. This is to separate the different intervals, 2 to positive infinity.
What about, oh, okay, because for negative infinity to
-2, it's
-2,
decreasing, right? So
yeah.
increasing means as x is going up, y is going up.
Oh, okay.
And decreasing means as x is going up, y is going down, or vice versa. So it's decreasing between -infinity to -2, and then union. Again, the notation, we're going to double check, see what your book uses. And then it's again decreasing between 0 to +2, exclusive. So I would say that's the answer for this one.
0 to 2, it's decreasing. Oh, okay.
Yeah.
Oh, because it's going like downwards.
Yeah, exactly. You can always just look at it as x values are going up, the y values are going down, right? So that means it's a decreasing interval here, also here.
Wait, because technically it's going towards like the positive, like for 0 to 2. But is it because it's going
Yeah, it's going
like
down, right?
down?
If you draw the tangents, if you know what that is from physics, maybe. See, all these are negative slopes. The linear function like this has a negative slope. So if you were to draw the tangents at any given point, all of these are negatives. That means those are decreasing intervals. Whereas if you draw the tangents here, all of them are positive. So that's an increasing interval.
Okay. Okay.
Yeah, so for increasing intervals, decreasing intervals, you don't include them. I would say it's the same for this one. Let me double check this 8A and B. Boom. Let me see if they used union. Yeah, they did use union.
Okay.
But they
And then
didn't
the
use
same
the
thing.
interval notation though. Which one do you use? Do you use the interval notation or do you use the XER notation?
Sometimes it's like both. Like it just depends on the question.
Yeah. So here, this means the exact same thing here. This is the answer to this. This means it's positive everywhere apart from -2 and +2, and that's what they have here. For A, this is the answer to A, right?
Yeah. Oh, so x can't.
So it's positive everywhere apart from -2 and 2. At that point, x is 0, sorry, y is 0. So it's neither positive nor negative.
Why is it? Okay, is it saying x can't equal
Yes,
-2?
yes.
Because that's when it's negative.
No, that's
Or
when
no,
it's 0.
0.
Positive means when the y value is strictly positive. 0 is not a positive number. It's neither it's neither positive nor negative. So you don't include them.
Okay, why is it in like the positive though? Like for the answer, if it's not.
Where? For A?
Yeah.
No. When x is -2, y is 0. That's why it's exclusive.
Oh, okay.
See, this means the exact same thing as this. It's positive between -infinity and -2. Yeah, because at exactly -2 is 0, so that doesn't count. It's again positive between -2 and 2. And same thing, 2 to positive infinity. At exactly 2 and -2, it's neither positive nor negative. That's what this means in set notation.
Oh, okay. Okay.
And this one, same thing, between -2 and 0, it's increasing, and from 2 to positive infinity, it's increasing. Same thing we have here in interval notation. And then everywhere else it's decreasing. So for this course, both whenever they ask you for intervals, it is exclusive.
So it wouldn't be like the
It won't be a square
brackets?
bracket, exactly. Yeah.
Oh, okay, and like we usually do like the curly, is it curly?
Yeah.
What's
Yeah.
the
Curly.
yeah,
Yeah.
yeah, and then bracket, and then it would be like XER and then a line. Would you write like X cannot equal -2 to 2?
Yeah, exactly. So you would do XER, right? I don't know if you write a colon or a dash, and then you do X cannot equal -2 and 2 close curly bracket.
Okay, it's because at -2 it's at like 0,
0, exactly. Yeah.
and
So
then at 2 it's also at 0.
yes, and they don't count as positive or negatives.
They don't count as positive or negatives.
Correct.
Yeah, sorry, I might be repeating the same question, but then why is it in the positive? Like why when it like for the
Okay, I
answer?
understand the problem. I understand the problem. When X is -2, we're talking about the Y values. Y, when Y is 0, that's neither positive nor negative when the Y value is 0. So what's happened here? When X is -2, the Y value is 0. That's why at X -2, it's not a positive number. That's what that means. Same thing here. When X is +2, the Y value is 0. So that's why +2 is excluded. Here, let's look at
Okay.
another example, right? Here, let's say 3. So tell me where this function is positive.
At 3, like where is it positive?
Yeah. So how would you write it? Give me the positive interval for this.
Would it be like the same thing, like x equals all real numbers, and like the dash a semicolon, then x can't equal 3
Yeah, why?
because the y is at 0?
Exactly, there we go. So positive is here, negative it's nada. There's no negative intervals here. What about the intervals of increase?
Like same notation. Would it be like in negative infinity to 3, or is it infinite?
Where is it increasing? So again, look at it.
Oh,
Increasing means as
3 to
X.
infinity.
Yeah, 3 to infinity. So you'd write X is greater than 3. Okay, or
Oh yeah, x.
not inclusive though. It's not inclusive. Okay, because at
Okay.
exactly 3, it's neither increasing nor decreasing. It's 0.
So is it just x is greater than 3, or?
Correct, correct. It's exclusive. Whenever you're doing these interval questions, well, it depends on the teacher kind of, but your course is telling you to do is exclusive, which is what the book does as well, actually. Actually, the book does inclusive for zeros and then exclusive for intervals. Don't worry about the book. This course, this website is telling you to do exclusive for both.
Okay, and if it was like facing down the parabola, then
Let's make it a little bit more complicated. All right, let's do this one. Let's say this is -1. Let's say this is 2. Let's say this is 3. All right, we're going to do this one last question. Give me the positive intervals. Positive interval. Or is this positive?
oh, for the like x values, or
Yeah, I
okay,
mean, what do you think?
well, it would
When is
be
the y
from
value positive? For what x values is the y value positive? That's what it means.
for the x value, what y values are positive.
Yeah.
Well, it would be after like the y-axis, like everything to the right.
The y values are positive here too.
Oh, because it's increasing.
No,
Then is it?
nothing to do with increasing. It's above the x-axis. See, y value here is positive. Y value is positive.
Oh, okay.
Okay.
So negative, yeah, like -1, 2, yeah, and then would be 3 to infinity.
You see that? Positive intervals. Exclusive everything. Now tell me the negative intervals.
Negative infinity to -1, and then 2 to 3.
Yeah, perfect. There we go. Easy, right? Not bad.
Okay, and then for like the way that they did it, like the XER,
Mhm. So
would
you would do
like
XER and then you would say X cannot be, no, you would say, how did they do it? I think they said equals U, right? Yeah, they did the union version. So you would do, I don't know if that's the way you do it. Yeah, you do it like that. XER, yeah, X, like that.
do you have to put the XER, I mean
Yes.
XE, right?
Yeah, yeah.
Okay. And do you put the XE only when you do it with like the union? Like the two brackets, like,
Yeah.
okay.
Here, tell me the increasing intervals here.
Increasing?
Mm-hmm. Actually, you're going to need
Um,
this point. So that's going to be 0.5 minus 2.5.
okay. So like, would it be decreasing from what it like 0.5 to negative infinity? Or like, yeah, I was actually confused about this. Like, do you count from like, is it from like the left to the right?
Yeah, it's from the
Like,
left to the right. Yes, it's from the left to the right, not from the right to the left. Left to the right. So here, just ask yourself, from here to here, the x value goes up, right? Always from
yeah.
left to right, x values are always going up. Are the y values going up or down?
The y values are going up.
Yeah, so up until 0.5, the y values are going up. So that's an interval of increase.
Okay, so like for increasing and decreasing, it's according to the y values, not the x
Yeah,
values. Okay, then yeah, for decreasing, it would be like 0.5, negative 0.5 to 2,
2.5.
right? 2.5, yeah, 2.5. And then increasing again, it would be 2.5 to infinity.
Yeah, exactly. There we go.
Oh, okay. Okay, yeah, I get it now.
Alrighty then. Okay, I'll upload this video and I'll see you when I see you next time. Just do the questions from the book, I think. Or do you even have the book? I'm not sure. I can send it to you.
Oh, the book, like the textbook?
Yeah, you can do the example questions like how they do it. Like you'll see because here they don't show you the steps, right? They just give you the answers. Maybe they do in the lessons themselves. I'm not sure.
There's a solution section. I'm pretty sure they actually explain it
All
like
right,
in
yeah.
there for some of the questions though, not all of them.
Yeah, I guess you can just practice some of them. It's not that bad. Once you get a hold of it, like it becomes pretty easy. This unit is not that bad.
Oh, okay.